Hey everyone, and welcome to the live stream. Hopefully you guys can all hear me. Put that in the chat if you can, and tell me if it's too quiet or too loud or anything out of the ordinary. Okay, so I guess we should just begin. Okay, it's a little quiet. Let me see if I can turn up the volume. Let me know if it gets a little bit louder. Is it better now? Okay, I made it a little bit louder, so. Okay, so this is what we have to build today. We have to build the TVC mount, the rocket, and just pretty much everything. You can see the flag meter right here is fully assembled already. But we have to put together the rocket, we have to put together the TVC mount, and get it fully assembled for tomorrow's flight. So I guess we should just start by going over the components today. So this is the flight computer, which controls the entire rocket right here. This is the airframe, which is what everything sits inside. We also have the coupler, which is an adapter for the airframe to the parachute ejection system. Here's the just a second. Here's the ejection system, right here with the parachute attached already. And then this is the nose cone. So we have to put all of this together and then assemble our TVC mount. So I guess we should start assembling the TVC mount first. Okay. So I started a tiny bit of the assembly, but not very much. I just put this on the motor tube. Well, it's probably going to take us a while to fully assemble this and get it nicely tuned in. Okay, you want me to move the screen? Is that better? I use an E-match to ignite the black powder for that fires the parachute. And I'll show you that when I put together the parachute ejection system. But first we have to put together this. And you might notice that you can see my 3D printer on the right side, the top right side of the camera. So I think I have to 3D print a motor adapter today, so that'll be interesting to print and see. You guys can see it. So let me plug in my 3D printer real quick, and let's turn it on. I use an Ender 3 Pro. So you can see it just turned on. And tell me if the camera's too far back or anything. And we're going to be 3D printing it in this silk POA, which is the same stuff as this. And this is the part that we're actually 3D printing today. It's this. It's what houses the motor and sits inside the TVC mount. Like that. But this one is a bad design, so I'm going to be 3D printing a slightly different one today. So, let me Let me start the print real quick. Okay. So it should start in a few minutes. Let me know if you have any questions in the chat. This body tube, this airframe right here, took I think 20 hours to 3D print. I had the settings not right on that. That's why it took so long. The last one, the gray, the silver tube that I used for the earlier flights, that one took like 10 hours to 3D print, so I got the settings wrong. But the mounts for the electronics. No, this is I fully designed this myself. This flight computer and the code for the rocket, as well as the TVC mount. How many flights I'm planning to do? Pretty much as I'm probably gonna do maybe 15 flights, as much as it takes to fully verify the system. Okay. The 3D printer is heating right now. And I guess we should put together the TVC mount, so let's grab one of these linkage stoppers. So I'm just going to unscrew the nut on the back. And the easiest way to do this is, because it's a tight fit in the TVC mount, I'm going to put it in my drill and do it. Okay, got in my drill, and I'm just going to thread it on to the motor tube. It might be a little bit loud, but it's just going to be for a second. I just need to thread it in. Hey Yukon. Hey Orion. Okay. Oh, I see the problem here. I accidentally did it wrong real quick. Let me take this off. Now it should put it on properly. Don't ping Joe in Discord. He doesn't need to be pinged. I'm gonna go away just for a minute so I can screw this in without it being too loud for you guys. Okay, got it screwed in. You might be able to see my 3D printer starting right now. Okay. Oh, it's time to do this. Let me just turn this. The fully sized rocket will fly. I don't know, I don't see a really real benefit to this. This rocket is harder to stabilize than that one. So, I guess this one for now at least. Maybe I'll fly the bigger one, the fully sized. Okay, looks like it's printing. Yeah, McMastercar is the place for a lot of stuff. I think I don't remember where I bought these. I think it was wherever the website that sold them was. Okay, so you could see I got that pretty good. It's really sloppy. Oh. Duh, I forgot this part. Yeah, I'll be right back. I need to get these screws, that's why. It's really weird. Okay. So you should be able to see my printer right now. Hey JJ Aviation, Yukon, I'm not using my Octoprint. Oh, it's the same camera, but it's not through Octoprint. But yeah, it's the same camera that I use for Octoprint. It's nothing special, it's just like a 1080p webcam, I think. But it works fine for 3D prints. Okay. That's one screw. Hey Drew. Okay. It should be screwed in now. Okay, I'm almost done with the inner gimbal right now. Sorry for not answering questions right now. I'm just trying to get... Oh, that's the reason why this isn't going in. There we go. Okay. Just like that. And screw it down. Okay, now it's time to screw in the inner gimbal screws. It's a little bit too tight. Boy, this is interesting at all. Okay, it's got really nice movement now. So let's test it with the flight meter. It's fine if it's not perfectly offset correctly. We just want it to be working. Yeah, I don't know how well you can see that, but it works. And then if we do a simulated flight, see, it's working. It's just a little bit offset, but I can counteract that in software. Okay, time for the outer gimbal. I'm using the same outer gimbal that I flew in the last flight. I'm trying to reuse as much as I can, but I'm going to be switching out the servo because the servo broke last flight. So. To be honest, I don't know why this nose cone is this shaped. I've just had all my nose cones look like that. I don't know, it's just the design that I go with. I'm not going fast enough that it affects aerodynamic properties, so it doesn't really matter. But yeah, when I get up to higher speeds, I'm gonna have to go with like a parabolic nose cone. Okay, the print's going along fine. Okay. Yeah, I think I used to follow Dave's rocket shop. It's fine though. I'll probably design one. It's not too bad to design one. And because I'll probably simulate it too. So I'll keep that. This servo I don't need. And then I'll use this new servo right here. Let me know if the stream quality is okay. I haven't done a stream in a while, so. Okay, so I'm gonna put this new servo in, and then screw it in. I'm probably going to do 2 more flights with the E12 motor, just to test things, because I don't need to scale up before I actually know that it works. Then I'm probably going to go to the G25, and I'll do a static fire first, of course, or I might do the F15. I just need to get a successful ascent and descent. Last flight should have worked, if only I accidentally didn't turn the derivative value too low, and I should have connected the pyro channel properly. But okay, now I have to get this other linkage stopper on. And washer off. Okay. I'm gonna put this back in my drill. Okay, I'm gonna go away just so I can drill it in real quick. Oops. Okay, so the TVC mount is mostly assembled. I'm gonna put on the last parts right now. Hopefully you guys can see what I'm doing right now. Just get those aligned, then screw it in. Okay, got that on. Next, the servo horn, which should pop in there, and then I should just slide in to the linkage. I'm not in space race with VPS. Joe is way ahead of me in terms of TVC rocketry. The print seems to be going good. Okay, just got the linkage in. Just tighten down the set screw. Okay, so I can get so far. Maybe once we're done assembling the rocket, we can do trivia if you guys all want to. Let me just tighten the linkage stoppers now. Okay, and tighten this one. And then screw down these screws. Okay, let's do a actuation test with the flight computer. I just organize my tools. You can see the TVC mount and the flight computer right here. I aim it so you guys can see the actuation. Yeah, so it's way too far over there. Okay, so I'm gonna have to change that real quick. That shouldn't be too hard of a change. I'm just gonna have to loosen some stuff up. Yeah. I'm going to have to redesign my nose cone soon though, because it's going to be reaching speeds past 30 meters per second. But right now it's not, so. Okay, let's align that. Now let's recenter it. And then slide it again through. There. Okay, so that should be a lot better now. Just tighten this up before we screw it all back together. Okay. There, that's perfect right there. Okay. Fix that. And I can counteract any like 1 degree error if I need to in software. Wow, 15 people watching. That's pretty good. Okay. Okay. So I'll show you guys what it looks like to see it launch. See right there. You can see this is one direction, and that's the other. And then that's recovery right there. Okay. Now it's time for some other stuff that we have to do. I never said I wanted to make a rocket that reaches orbit. Connor, what do you mean? Make sure the servos aren't connected backwards. Okay, I'm gonna heat shrink the ends of these so they don't get damaged from any anomalies. Because even though, like, when the motor burns properly, there's still soot that reaches up because it's such a short rocket. So I'm gonna plug that in. Turn on the heat gun. And then let's get some heat shrink out. Thanks, Yukon, for timing him out. Okay. Let's see this. I need to find the smallest heat shrink that fits over the... Yeah, I'll just go with the size bigger. This should easily fit over. And then let me turn the temperature down. Oh yeah, Connor, I already, I think it does do that, and if it doesn't, then I could just easily flip that in software. The only thing that would really, because I've flowed this design before, so the only thing that would cause that is if I just plug them in to the wrong port. And I would notice that because this offsets, that would be way off. Okay. Let's get this one. I don't care about the nose cone. I know it's a bad design. Yeah, it's not meant for aerodynamics. It's just meant to have a thing. It's just meant to have. It's for aerodynamic purposes. So there's not just nothing on the top. That's pretty much what it is. Okay. Let's heat shrink these now. Yeah, and on my first flight, it was like a pretty much stable TPC rocket. And the second and third were just a software error. And I fixed the error now, so Connor knows about that error problem. But yeah, you can totally fly a rocket without that. But I'm trying to go higher than the C6 motor now, so it's just gonna allow the TPC to not work as hard. This should help reinforce the servo connectors right now. That's basically what I'm doing. Okay. Yeah. Okay, so these should be pretty good now. Now I'm going to put this aside for now and work on the rest of the rocket. Okay, now it's time for the pyros ejection system. This is actually 3D printed in carbon fiber PETG. My friend helps sometimes, but since COVID, I haven't seen him that much, so it's mostly me right now. Okay, so that's how it's gonna sit in the coupler. And I spent a couple designs making this thing lighter. On the original, on the Flight 5, this thing was like 65 grams, and now it's only 30. And there's only one layer of plastic. But if I have to 3D print it again, it's fine for the extra weight reduction. Okay, so oh hey Omar. See where it aligns. There is the screw hole. So what I like to do is I like to put an Allen key or an Allen wrench or a hex key or whatever you call it, but in the hole. So now it's going to be easier to line the other ones. And if I can find the other one, should be right there, yeah. kind of hard to align it. It's not the design's fault, I guess, but it's hard because the eyeball just kind of sticks out the bottom. I would really like to build a Starship model rocket with controlled canards one day. That'd be pretty cool to see fly. Definitely not right now, though. Okay, there's one, and then two. Now it should be held in pretty good enough that I can screw one in. Or if I even pull it on here. Okay, it's screwing it nicely. I just had to get it aligned. Connor, I'm 3D printing a 29 to 24 millimeter TVC adapter. So it basically allows my TVC to work with 29 millimeter motors, which is what I use for the E12. Yeah, it's a better idea to launch a rocket with TVC before you actually go, or launch a rocket without TVC before you go and fly and design and try to fly something with TVC. It helps a lot to actually know what you're kind of getting into in rocketry before you design a giant project. That's why I started, like, the first year, I just designed a couple, and then also bought a couple commercial model rockets and just flew them to to learn the ropes of rocketry, kind of. And then since 3 points define a plane, I should only need 3 screws to screw this in, and then the rest should be easy. Oh, hey, JJ. That's pretty cool, Justin. Is it using TVC? Because it's gonna be kind of hard to control an offsetted thrust like that. Okay, so this is how the nose cone will it'll sit like that, kind of. But I may need to go get a pyro. Yeah, I may need to go get a pyro. Let me see if I have one. Yeah, I don't. I'll be right back, everyone. Oh, hey, Phil. I'll be right back. sorry guys, I'm back now. Okay, so I got the pyros. These are just simple fire reigniters. They're pretty reliable, that's why I use them. But basically what I need to do is I need to just feed it down through that. But first, one of the upgrades that I'm doing for this fly is I'm heat shrinking this part too. So hopefully it allows me to get a better contact and have more reliable. It should allow me to have a more reliable connection. So I'm gonna pull these two wires apart and put some heat shrink on each one. So I should be able to put these small heat shrinks on. Okay, so got that ready. Let me heat shrink this real quick. Yeah. It honestly, to test my TVC, I might put like a weight on one side of the rocket. That would be interesting to see if it could correct. Or I might just put like a little like C motor on the side and then have the main motor try to correct. That would be pretty interesting to see if it fly like that. And that would give me more like that would probably give me more reliability if I knew that it could stabilize because I'm planning to use multiple motors in the future. If one motor goes out. Okay, let me just fold this down. Okay, and then the rest of the heat shrink. Okay, so now I should have very solid connections for the computer, which is gonna add some reliability to the next flight. Okay, so I'm just going to feed these down through the ejection system. This might be a little bit hard to do. I have to do one at a time, actually. JJ, I'm 3D printing a 29mm to 24mm TVC motor adapter. So I'll be able to use the E12 rocket motor. Come on. It's so close to getting through. I probably should have done this on the other side. Yeah. I'm gonna try one more time. I might have to redo this if I can't get this to fit through both of them. Yeah, I don't think I'll be able to do it. I'll use this for the launch pad side then. I'll just have to do this again then. So I'll just feed that down. This channel is probably not gonna get monetized for a while. Okay. Now time for the same thing that I just did, but again. No. Well, it's 1,000 subscribers, but then you also have to get 4,000 watch hours, like 4,000 hours of people watching your videos, which is much harder to do. I think I have like around 700 or something, but it has to be public watch hours. So yeah, it's at least gonna be I would say, at best, it would be the end of the year. Okay, got one. Let me know if this is interesting at all. Okay. Those are looking pretty good for the flight meter pyro. You can see they're nicely heat shrunken now, so should be good. I'm gonna undo the parachute right now because it's just a hassle to have it on. Okay, so I'll put this on when the rocket's fully assembled, I guess, or something. Okay, the next part is, I guess wiring up the flight meter for this. So these things will just come through the side. I have to actually do this properly this time. Last time I did not, and I saw the consequences of that. Come on. See if I can use this. There we go. Okay. Actually, the print's still going well. I think it's halfway done. Oops. Okay, this needs to come through from over there. Just gonna push those in and tighten them up. Okay, that's good. And then the other one. Oh, I didn't do my heat shrink properly. I guess. Well. I don't know why this all of a sudden does not want to screw in properly. That's, I guess, why the last flight failed. There we go. We have to desolder this terminal block soon. It's getting worn out. Okay. Should be good now. Just slide in there. That. See if the drill. Yeah, I guess it's pretty screwed in there now. So that other one's nice in there. Okay, so you can see I connected up pyro channel 2 to that. So you can see it's nicely fed through this zip tie that holds on the battery. Next up is connecting up the TVC. Okay, so I'm just going to make sure these are connected properly. A hydraulic TVC mount would work. It would be hard to get a fast reaction time, I think, though. I don't know, you might be able to get it to work, but from what I know, it might be hard. Okay, let's make sure. Let me try that again. I don't know why it sounds weird there. Things are going good. I'm just integrating everything real quick before I put it in the full rocket body. Okay, everything's good. It's time to put it all in the airframe. So I'll slide in the TVC mount first. Actually, I'm just gonna zip tie this real quick. You probably shouldn't use zip ties, but I like zip ties for this. I don't do it too tight, just enough to kind of hold it in place. Yeah, things are going good. I hope the test flight tomorrow is successful. I'll probably upload a video to YouTube for the next couple test flights or something. Okay, tie enough, and then let's chop that off. Okay, now these, let's make sure the wires for the pyro are nicely still in there. So it would suck for those things to come out before it flies. Okay, I think it's ready to go in. TVC mount first. Kind of a little bit tedious to do this, but slide the TVC mount down, slide the flight meter in. And now I'm going to secure one screw for the flight meter and one screw for the TVC, just to hold it in while I finish putting up everything else. Okay. Is that the hole for that right there? Okay, there it is. Yeah. Okay, got the flight meter secured with a screw. And now it's time for the TVC mount. The TVC mount's the hardest thing to secure on this rocket because it's hard to get it aligned at first. But then once you do that, it's not too bad. So I'm just gonna get it aligned with the Allen wrench and screw this screw in. Is it even screwed in there? Let's take that out. I think it's screwed in. Let's move to the next one, I guess. And let's secure over there. How many hours of work? That's kind of a difficult question. I work on it like almost every day. Yeah, I would say I work on it almost every day. And I probably work on it for like 4 or 5 hours a day. Well, depending on what I have going on, but sometimes I work on it for a long time. Like when I'm designing PCBs or something. Okay, let's flip it over. But I started back in 2017, so it's quite a lot probably. And you can see the TVC at the bottom. Let's see if I can get that square. Okay, there we go. Now I think it's time to screw in the coupler, so let's flip that over, turn that, push that. Let's screw this on. Thanks, Omar. Okay, we can finally stand the rocket up. I'm gonna use my drill from now on, though. Okay, so you kind of see what it's coming together. There's two. finish screwing on the TVC mount. I work less on school days, but I still try to get in as much time as normal. Let's see. Sorry, I hit the microphone. Perfect. Dang it. It's not like being screwed right there. It's not a big deal though. Kind of short in M3 screws. I probably need to go get some more soon. Oh crap. That's not good. Since this thing is one layer out, it just immediately cracked. Because I screwed in and not perfectly straight. Okay. Parachute ejection system is mounted. Now it is time to finish screwing in the TVC mount and the flight computer. Okay, this one will go to that screw. I might not have enough M3 screws. I'm trying to not use that much. This rocket takes so many. Like 6, 18. Yeah, this rocket takes 24 M3 screws. Actually, wait. No, this rocket takes 32 M3 screws, which is a lot. Right now I think I'm using like 20 or 22 right now. It saves weight, and it's not like it needs to be crazy rigid. Because the more rigid, the more the plastic has to flex in order to save something, like if the PCB broke. If like the PCB was going to break or something. But this is the last screw. There we go. And you can see here's the rocket. So if I turn it on, you guys can see it start up, hopefully. Okay, it sounds good. I guess it's time to put on the nose cone. I made this thing so I have to file it out. little bit of sanding, and then it should fit really nicely. I made it for a super tight fit because this is for a different nose cone design originally, and I forgot to update the actual Fusion file. So let's see. Yeah, there it fits now. Let's make sure it's not destroying anything. Yeah. See, it's pretty nice looking, except for that silver part at the top. I'm not taking moderators right now, but maybe in the future, if you're on a couple more of my streams, maybe I'll let you be a mod later. I'm gonna start trivia soon. Let me just put it on the launch pad and just let it start up the start sequence. Oh wait. I guess I can answer trivia soon. Let me just make sure the rocket is It should work. I might have to take it apart tomorrow. It's gonna be annoying if I have to take it apart, but yeah, the server link should be in my last video description. If you go there to that video, you should be able to see it. Yeah, I might have to take it apart to tune the servo horn things. But I'm definitely gonna have to code the offsets later. But I'm not gonna do that on the live stream. I guess it's time for a little bit of trivia. I'm probably gonna head out soon. Maybe in 30 minutes. So let's do some trivia in the meantime. Maybe I'll stop the stream when the 3D print finishes. What are the parts for the TVC mount? There is the inner gimbal, the outer gimbal, the motor tube, and then there's some screws, servos, push rods, and linkage stoppers. Thanks, JJ, for posting the link for my Patreon. Okay, shall we do trivia? Let me know. I'm gonna create a straw poll, I think, for the trivia. It's kind of hard to do this because my computer is not at the correct orientation. I think we have to get 4 votes on this. I don't think there's that many people. Multiple question. Let's go. Let's do SpaceX, NASA, and then T, C. Okay, I created the straw poll. Put it in the chat. There will be Delta Space merch, maybe maybe in September. I've already created a couple sample ones for like just like seeing if they printed okay. But definitely, well, there will be some soon. Okay, created the link. Vote what trivia type you want. Let's see which one is winning right now in the poll. Come on, people, vote. There's only 2 votes. It's a pretty simple print. Let's see how it's doing. It's pretty smooth. Yeah. The question, well, I needed to get enough votes, but it's just gonna be like whatever trivia you want. Like if you want SpaceX trivia, TVC or NASA, whatever you guys want it to be. Yeah, Omar, there's no question yet. I just need to know what genre. I think SpaceX is winning. Yeah, SpaceX is winning. No, you cannot spam SpaceX. I think Connor wants to do capacitor trivia. I think SpaceX won. Unless anyone else is gonna vote still. I'm so nervous for tomorrow's launch. Dang. That's gonna be... Hopefully, I got the scent thing dialed in. I'm not worried about the ascent. I'm worried about the parachute deployment and stuff. So far, I haven't had a success, but it doesn't seem too hard. TBC trivia, but there's only one vote in that so far. Oh, there's 2 votes now. 60-40. If one more person votes, then we'll have to do then I guess we'll just do like, we'll ask a couple people in the chat only. Connor, I get that you want BBC trivia, but it has to win. I feel like TBC trivia is gonna be way too easy for the people that that actually do TBC, which is like the entire chat. This is gonna be interesting either way if TBC trivia wins. One hour and 30 minutes. That's pretty long. How long the stream has been? Okay, it's 60-40. Here, let me change the camera so you guys can see the print. Let's see if you guys can see the print a little bit better. Yeah. There you go, it's a little bit better now. What breadboard do I use? I just use I don't use a breadboard, but what I used to use is just like the standard. Whoever makes it, breadboard. Ask Connor. Connor has way too many breadboards. Or ask Payspace. Let's see. Is it still tied? Is it? I think SpaceX Trivia won. Yeah, Connor has a lot of... Connor has a lot of breadboards, so... If anyone knows the best type or anything, it's him. Yeah. I've used proto boards, but they're just like the generic ones. I would recommend if you have a soldering iron and you want to just like experiment and you want to fly TBC rocket, I would definitely recommend going with the Adafruit proto board that is like a breadboard, but it's just soldered. You use solder instead of like non-permanent connections, and it connects everything in a row, so it's super easy, just like a breadboard. Yeah, proto boards are solder. Some are the ones where you have to connect wires from each thing, and then some are the row ones. I recommend the rows. So it's essentially a breadboard, except you use solder, and the whole one is pretty much just a ton of pins that you can do a lot more on the whole one, but it's harder to use. Definitely recommend either a breadboard or the solderless breadboard for your first time. guess that's pretty clear. SpaceX Trivia 1. Geez, we got to 19 viewers today. That's crazy. I think that's my highest that I've ever gotten in one stream. Yeah, you can. Yeah, the ones without the rows are you can get a lot more compact, but they're. It feels like a lot less of a. I feel like there's just more things susceptible to air, because you have to do wires between each thing. But it's probably fine. It's a little bit harder to use though too. Okay, I guess it's SpaceX Trivia. What SpaceX Trivia do you guys want to do? Just answer in the chat, like Falcon 9, Dragon, Starship, like what kind of rocket trivia, or just like SpaceX like history, or something. Okay, Falcon 9. Yeah, Starship is BFR basically, but history is pretty cool. I really like Starship, but there's not as much information I think about it. There might be, but let's see. So Starship, Falcon, Starship, history, Falcon. So I think there's one, two. I have an Ender 3 Pro. It's like fairly upgraded though, so it's not really stock. But it's essentially Ender 3 Pro. I think Falcon 9 wins. So, let me think of a question. Okay, they're not going to be too hard, because I'm not like a SpaceX studier of Falcon 9s. I like Starship more, but what was what was the second version of the Falcon 9 called? Like the second block change. Let's see, first person to gets it. Now that's the latest one. The second one. Not Falcon 9E. Not Mark II. It's kind of a hard question unless you know what it's called. Kind of. It's not like a simple name like Mark II or like something like that. I don't think it might have been called Block 1.5, but the name of it was Falcon 9 Full Thrust. Hey, Raccoon Technologies. Right now I'm basically waiting for this print to finish. It looks pretty good. It it'll probably be done. It's probably gonna be done in 30 minutes or less. Dang. 704 subscribers. Maybe when we get to 1,000 subscribers, I'll give out like a free TVC mount or something. I plan on flying my rocket tomorrow, actually. Yeah, it's gonna fly. I'm trying to fly it as often as possible so I can rapidly iterate the design. Thanks. I hope it goes well. I've been having lots of problems with the parachute system. I think I got it down. It should have deployed last time, except it wasn't connected properly. But this time I made sure that it's rigidly secured, so it should deploy. I'm launching in Pacific Standard Time, so it's 3 hours behind Eastern Standard Time. I don't know where you are, but yeah, shoots do not want to deploy. The problems that I've been having are connection and the software. I think I got the software down though. It should deploy reliably every single time now. If I get it connected properly, at least. And then I also think the ascent is it's working pretty well now. Hopefully I can keep it up though. Thanks. If it doesn't work, I'll probably fix the issue. The data logging helps me so much diagnose what happened in the flight though. Like last flight, it tried to deploy the parachutes. I saw on the state machine it said like parachutes deployed or whatever, but it didn't fire it because it wasn't connected properly to the pyro channel. Oh, you're in the east. If it doesn't work, I'll probably fix the issue and fly it again. But tomorrow or tonight, whenever I get to doing this, I still have to put the parachute on, put the black powder in. Yeah, do that, and then also I have to tune the TBC because right now it will just pitch itself over like 30 degrees. Yeah, data logging really helps. Yeah, I use Autodesk Fusion 360. Yeah, I would get an Ender 5 Pro if I could. I I am a big fan of Prusa though, so I would probably get a Prusa MK3S or something. Or a Prusa Mini. Um, Connor, what I mean by it pitching over 30 degrees is if because it's not aligned right now, the TPC is like super far off. So, but that's because I put together new TPC mounts, so I'll just have to change the offsets. The Prusa Mini sounds super cool. I was actually going to buy one instead of my Ender 3, but the shipping is just like crazy. Like it's gonna be hard to go like 6 months without 3D printing anything, especially like a TVC mount or anything. So yeah, the Ender 3. But yeah, tonight or tomorrow I'll go in the software and change the servo offset so it's nice and aligned for tomorrow's launch. I sometimes do that at the pad so I can make sure it's aligned right before launch. That's what I did. That's what I did the last launch, and it was pretty good. But I don't have to do that because it also calibrates the gyroscopes there. This print is taking a while. I guess I could speed it up a little bit. Let me speed it up. It doesn't need every precision made part. It just needs to be able to slide in the TVC mount. So let me just speed it up 25%. Orion, my TVC mount is super easy to align because it basically shows you if it's properly aligned or not. The problem is it's hard to do it when it's in the rocket, so I should probably 3D print some like a jig that allows the motor to slide through when it's perfectly aligned. I'm a student, so Fusion 360 is free for I think educators, students. Yeah, I think. Yeah, me, Connor, and then I think also Yukon. I don't know if Orion does, but most of the Rocketeers use JLC PCB. I think Joe uses PCB Way or something. I don't remember what it was, but I use JLC PCB because it's super cheap, and it's a sister company to where I design my PCBs too. I bought some polycarbonate recently, so I think I'm gonna try printing my TVC mount in polycarbonate, and it's gonna be either it's gonna print well. I don't think it's gonna print very well because I can't use cooling fan, but it's gonna be crazy strong. Yeah, JLC PCB is pretty good. The cost is $2 I think for PCBs under 50 by 50 centimeter, 50 by 50 millimeters, and then like my PCB is over that I think. Yeah, it's over that. So I think mine's like $6 or something, but it's pretty cheap. Yeah, the shipping is the bad part. The DHL shipping is like $20 or something, which is like who cares if the PCBs are $2 if the shipping's so costly. The shipping time is pretty good if you use DHL, but it's expensive. It's like I don't remember. I think it's 3 days or 4 days or something. PCB weighs 1 day? Dang. The PCB is on the YouTube channels in the one of the videos. I think. Yeah, I think it's called like Omega Avionics or something like that. But yeah, that covers the PCB. TVC mounts, or the TVC thing is almost in printing. I just got some more E12 motors today. E12s are pretty nice motors. Yeah, I remember reading that somewhere that PCB didn't have good quality control. That's one of the big reasons why I went with JLC PCB. I remember I was considering using Osh Park at first, but then I went with JLC PCB because their company, I don't know what it's called, but they have like a sister company called Easy EDA, which is where I design it, and then also LCSC, which is where I get the components, or most of them. Some of them I get from DigiKey and Mouser, but GLC PCBs manufacture them really nice though. I don't know about PCB wood because I've never tried it, but JLC PCB, there's nothing wrong normally. Well, there's nothing wrong on the PCB, so. I got PCBs, like I got my first PCBs back in like September or something. I don't remember when, but it was early starting TVC, and it's just something that it's for the flight computer, and it's better than like a breadboard or something. You guys still want SpaceX trivia? I can still do it if you guys are up for it. Their print should be finishing very soon now. It looks almost done. Should start doing the top part in a minute or two. Okay. How much is Frontier weigh? Well, it depends. Like this one right here, I think weighs about 650. Yeah, I think about 650, or It might be 640 or 630, but I don't think it's more than 650. But yeah, that's how much it weighs. It's pretty heavy. I could honestly decrease the weight. The last one weighed even more. Frontier Flight 5 and Frontier Flight 4. Or no, only Frontier Flight 5. That one weighed a lot. And since then I've decreased the weight by like 60 grams. And that's why I'm able to go slightly higher now. But for the next one, I might even decrease the nose cone. I might be able to get an extra 30 grams or 20 grams out of that. EV1 is a very good name. That would be a good launch computer name. Okay, it's printing the top of the mountain now. Yeah, it's looking pretty good on the top now. Might stop it a little bit early so I can save a little bit of weight. This entire rock is pretty much a weight game. I just want it to go as high as I just want to get as much weight, less weight as possible. I mean, to really save weight, I would reprint the airframe again. That's something that will definitely decrease the weight. I could probably decrease that by at least 30 grams. In total, I could probably get it maybe even 100 grams higher. Yeah, I think I'm going to stop it right now. Okay, I'm stopping the 3D print. So, so it could save a little bit of weight. Yeah, it doesn't need to have that part. It's a little bit hot. Let me let it cool down for a minute or two. But here's the 3D print. I don't know how well you guys can see that, but Teensy is kind of expensive, but I think you're getting a lot of what you pay for. Like, it's not much more expensive than a genuine Arduino off the Arduino website, so. And you're getting a lot more. Smaller form factor, more I/O, more flash, micro USB, and faster clock speed. And I think you even get a floating point unit on, I think, the Teensy 3.5 and 3.6 or something. I don't know which ones, but so let's get it off. There you go. Not too bad of a 3D print. I'm not trying to go from quality, so it's kind of 3D printing pretty fast. Just put that back on. It's not aligned properly. There we go. And then I'll just do a test fit with a D motor. Yep, it looks like it's fitting pretty nicely. I don't want to shove it all the way in. But yeah, this will just fit in the PVC mount. So that's the last part we need for the rocket. The TVC does not move with the tilt of the Arduino or the teensy. It moves with the tilt of the inertial measurement unit, which in my case is the MPU, which I don't recommend, but yeah, it basically moves with the gyroscopes. There's a lot of post processing you need to get it to work properly with them, and you need PID values to actually send actual good orientation to it. But yeah, I think I'm gonna end the stream in a minute or two. It was fun doing this. I got what I needed to accomplish tonight, including the rocket and the adapter. Okay. I already did assemble it. I assembled it. That was the first part of the stream. You can go. I think you can go back in the stream. Just go back to like maybe 10 minutes in. That's when I was assembling the TVC mount and everything. But it was fun streaming. Thanks, Meepers. I hope the flight's good tomorrow. Yeah, I'll post on like Twitter and Discord the result. And I will play KSP. And I'll see you guys later. Bye.